Assalamu alaikum, Ramadanul Mubarak. My name is Mohammad Nafees bin Zaman, and I'll present my part of Big Data Analytics presentation. So our topic is Airlines On-Time Performance Predictive Analysis. In the introduction, I want to mention that aviation airlines are used almost everywhere. If you know about Dubai International Airport, thousands of flights fly every day on an average. Thus, flight delay issues are one of the main concerns of airline business companies. Many customers have important meetings to attend, but due to flight delay, they cannot. Even delays can dampen the image of an airline business, whereas customer satisfaction should be their main priority. Based on this, we got a research question, which is, would a specific flight experience a delay or not? So our research hypothesis is delays can be identified through the month, airline, day of week, flight number, origin airport, destination airport, and scheduled departure of a flight. Here, delay is the dependent variable and rest of other variables is considered as independent variable. The research objective, we actually concentrate or focus on operating RStudio and Microsoft Azure with performing data analytics. We also try to identify whether a flight would experience a delay or not, and also evaluate the outcomes of our results. For the research significance, our main aim is to help both airline companies and airline agency firms. Airline companies could use the data to try and find a solution for the specific periods of time that they normally have many delays. Airline agency firms could use data to recommend customers that need to arrive on time with a suitable flight.
Assalamu alaikum, I am Abid and I am going to talk about the previous works done in the flight delay prediction field. So this is our literature review summary. So in the first paper, the Nigam and Govinda proposed a cloud-based flight delay prediction where in Microsoft Azure they developed a logistic regression model and they got the prediction accuracy around 80%. So in the paper they suggested that for the future work they are going to add some more models, for example supervised models like artificial neural network supporting vector machine and etc. And they will see whether their model performs better or not. In the next paper, Manna and his peers, they predicted their flight delay using gradient boosted decision tree and they got the accuracy around 95%. But the problem with this research was their recall and precision was pretty low. Their precision was below 50% and their recall was around only 13%. So what they proposed in future is that they are going to increase the number of airports, and so that the data will be bigger and the data would not be overfit and they will get much more reliable accuracy in the future. In the next paper, they used the Bayesian network model for analyzing the flight delay for time series data, and their prediction accuracy was pretty high and it was reasonable. And in some of the paper, what they did, like this one, number 4 and number 5, what they did was they tried to the number 4 one was to try to optimize two different types of algorithm. So they used the ant colony optimization and generic algorithm, and their model was able to effectively optimize flight departure. And the next, Gopalakrishnan and Balakrishnan used the Markov jump linear system, classification and regression trees, and artificial neural network to make a comparison between these three models in the case of flight delay prediction. And what they saw that ANN provides the highest accuracy around 70%. So they were in future they were thinking about improving the ANN accuracy using ensemble methods. In the next paper, what they did was they got the dataset from JFK airport consisting of over 70 different airline, and they used the artificial neural network to predict whether this flight will face delay in the future or not. And their root mean square error evaluation technique was root mean square error, and they got 0.1366 in their score. And they were thinking of integrating fuzzy logic in their application ANN model as well. In the next paper, as it was seen, a lot of researchers are thinking about implementing long short-term memory in their existing network. For example, network this paper, this article already implemented traditional neural network, and it had the accuracy around 71%. So they thought that using deep learning technique, whether they can implement the accuracy or not. So they saw the accuracy was much higher than the traditional neural network, and it was around 88%. So in future, what they were trying to do, because in their dataset they had only around 20 to 25 minutes of delay, so what they were thinking about making the magnitude of delays much longer. In the next paper, they used the artificial neural network to predict, and in future they were thinking of implementing recurrent neural network. In the last paper, it was talking about big data and how to implement using big data and machine learning in together. So their data was huge, and that's why they use the map reduce technique, which helped them to break data into smaller partition and use random forest on them at once, and then they combined the accuracy and they got the mean accuracy around 86%. So based on the literature review we have done so far, so we think that for our project gradient boosted decision tree, the implementation of gradient boosted decision tree predict higher. So for our project, we will implement decision tree along with the 2-class boosted decision tree to see whether we can get the accuracy around this 90%, or we can improve the number of precision, we can improve the precision and recall as well. So after that, let's talk about the methodology. So in the methodology, at first we collected our data set, which was taken from Kaggle. It was from United States flight data set, and it had 31 column and above 5.8 million records. The tool we are going to use for the data pre-processing and data analysis is RStudio and Microsoft Azure. So these are our project workflow. So at first we are going to use the raw data which we collected from Kaggle. Then we are going to pre-process the data using RStudio, and then we are going to do our exploratory data analysis in RStudio as well. And as we find out later that we tried to implement 2-class boosted decision tree in RStudio, but we were, due to our insufficient computer resource, we were only able to implement decision tree. So that we decide to use cloud-based service, and we use 2-class boosted decision tree on cloud. And at the end, from Microsoft Azure 2-class boosted decision tree, where we implement in Microsoft Azure, we get the data visualization as well as our product, so that we can see whether our product will perform better than the existing system or not. Thank you.
Assalamu alaikum. I'm Mahfuz. I'll be talking from the pre-processing part. So for our data set, we have cancelled flight, diverted flights, as well as the normal flight. And we have too many columns, as you can see from here. So for the pre-processing, we will consider the arrival delay only. And from the Federal Aviation Administration, they consider until 50 minutes as not delay. So this is the pre-processing code from RStudio, which is that we filtered out all the cancelled flight and diverted flights, and then we assign the arrival delay to a new column, which is delay result, After that, we factor the values as yes and no, which is delayed or not. So after removing cancelled flights and diverted flights records, we have no null values in the dataset, and then we select the necessary features from here, like month, airline, day of week, and so on. And then we change all the shorts name from, for example, for the airlines AS and original airport ANC, we change to the long name, so you can see from here. Moving to the EDA part, we have plotted the airline distribution, which means that which airline has the most number of flights and which have the lowest number of flights. Here, Southeast Airlines has the most number of flights compared to others. For the next EDA part, we have done the daily based flight system, and here the first day considered as Sunday and so on. So we can see that Friday has the lowest number of percentage of flights, and then from this graph we have plotted the monthly based flights. For example, we can see the second month has the lowest flight and the seventh month has the most number of flights. Moving to the model building part, we are using two class boosted decision tree. So first we tried to implement in RStudio. As you can see from here that we have uh, separate the data into training data and testing data and then fit to the decision tree model, and we got the accuracy around 81%. And then we wanted to implement the boosting algorithm, but because of the machine limitation we couldn't do that, so we used the Azure machine learning model. In Azure machine learning model, we need to set the learning rate and total number of trees for two class boosted decision tree model. So we set the learning rate as 0.2 and the total number of trees as 100, and here are the independent variables which will later on give us the value of delay result. Here is the diagram of the model. So first we insert the dataset and then we selected the column that I have mentioned in the previous slide, and then I have split the data into 80% of training set and 20% of test set, and then I linked with the two class boosted decision tree, and later on I have evaluated the model in terms of accuracy, recall, and so on. Thank you.
Assalamu alaikum. My name is Ahmad. Okay, so I'll be continuing about the results and so on. So from the model that we have actually executed in Azure, we got an accuracy of 81.7% and a precision of 55.7%. So from the first look, if we actually look into the results, it looks like the model actually performed well. But if we look into recall, we can see that the recall is very poor, which is only 3.6% here. So the reason that it actually got a very small rate here was because the data was actually overfitted. So from our target variable we have two labels, so we have the positive label and the negative label. So the positive label is yes, meaning that there is going to be delay, and the negative label, which is it's not going to have delay. So most of the data actually had a negative label, so around 80% or 81.6% of the data actually had a negative label, while only around 18.4% actually had a positive label. So due to this, when the model was actually trained, it became biased. So if we look into the confusion matrix here, we can see that for the negative label, it actually managed to predict most of the time the correct negative label. So from around 1.1 million negative labels, we can see that it predicted 926,000 times correctly. So that's around more than 80% times that it actually predicted well. But looking into the positive label, we can see that first of all, the positive labels are very little, and it only managed to predict like around 7,000 of those labels correctly compared to the total amount, so which is only like around 50%. That means for the positive labels it has only managed to predict half of the time correctly. So from this we can see that the model actually did not perform as well as it looks like if we just look into accuracy and precision. So moving on to the ROC curve, so you can see here that we have the false positive rate against the true positive rate, and it actually received an AUC score of 69.4%. So this is not very bad and this is not very good either, so it's just decent. And if the model was actually better, then it would have actually gone towards the top left corner. So moving on to the data product. So we wanted to actually bring in the business perspective from here. So what we did is we created a simple demo for using the Azure ML web service, where we can actually input the values and receive the prediction whether a flight is going to be delayed or not. So for someone that actually wants to know, he could input the information about his flight ticket, and he could actually try to find out whether his flight will have a higher chance of having delay or not. So inside here, what he's going to do is that he's going to fill up the necessary information, so example month, day of week, flight number, and so on. And the only field that is going to be left empty is the delay result, because that is the actual attribute that is going to be predicted by the model itself. So here's the demo outcome. So by the values that we tested by inputting, we got an outcome of no. So that means from the attributes that we put in, the model actually predicted that that flight would not have a delay. Okay, so for the discussion, first of all, that this research could be used as a business model, and where it's going to be a recommendation system for airline agency companies, where they can actually recommend their customers for a suitable flight when they are looking for a flight where they can reach their destination in the prescribed time, because they might have an important meeting to reach. So although this is the case, this model that we have at the moment is not the perfect one because of the data being overfitted. So therefore, if the data set was actually improved, this model could be much more reliable and could be used by customers. So in conclusion, the model is not unbiased, so it may not always actually provide the best prediction for delays, so we can't actually trust it all the time. So if we look into the machine learning algorithm individually, which is the two-class boosted decision tree that we implemented, the machine learning algorithm itself was effective, but because of the training being poor from the overfitted data, it actually created a model that was poor as well. So even if we used a different machine learning algorithm, it would have still been the same case. So from this we can see that the main problem was the overfitted data, and we can't actually just get rid of a lot of the data to try to neutralize the situation, because then most of the data would have to be removed. So the main concern here is that the data set should have been not overfitted and have a balanced amount of positive labels as well as negative labels. Okay, so considering the big data situation, so if our data was actually big data, what we would have done is first we actually looked into the RStudio open server, but we realized that it actually operates on the Linux system. So we opted not to go with that, and we looked into further options, and finally we decided that Google BigQuery would be a better option for our data warehouse. So why? First of all, if you go to the website, you can see that for registered users, they actually provide a free 10 GB space for each month, which would be more than enough for our situation, unless the data is humongous. So another really good benefit is that if we want to work with our dataset in RStudio, we can directly connect the Google BigQuery using the dplyr package, and we can actually perform all our main operations directly in RStudio. So for future works, what we would like is that we would actually have preferred to use a dataset that is not overfitted. So this would help to ensure that the model was not biased, And furthermore, we would actually like to improve scalability, which is the fact that this data set is only for US airlines. So there's a number of like around 14 airlines that were included. So if we could actually have records of airlines that come from internationals, so what would happen is that customers would not only be from US, but all of parts of the world. So different types of customers could actually use it to try to know whether their flight could have delay or not. And lastly, from looking into the literature review and the previous works, we can see that many people are actually using the deep learning techniques to predict this delay. So we would actually like to see how the deep learning technique would perform on this type of data. Thank you.